Hello everyone, we are Group 10. Our project is to make an intrusion detection system that can detect anomalous behavior in the network activity. My name is Rizal. I'm going to cover what is an IDS, the classification of intrusion detection systems, the detection method of IDS deployment, existing IDS software, evaluation techniques, and pros and cons of using IDS. An intrusion detection system is a hardware or software device that monitors a network for malicious activity or policy violations. A security information and event management system is typically used to report or collect any malicious activity or violation. Some intrusion detection systems can respond to detect intrusions as soon as they are discovered. These are known as intrusion prevention systems. It is a little bit confusing to you, so let me briefly explain what is an intrusion detection system and what is an intrusion prevention system. An intrusion detection system monitors traffic on your network, analyzes that traffic for signatures matching known attacks, and when something suspicious happens, you are alerted. In the meantime, the traffic keeps flowing. On the other hand, intrusion prevention system also monitors traffic, but when something unusual happens, the traffic stops altogether until you investigate and decide to open the floodgates again. Classification of intrusion detection systems. Intrusion detection systems are intended for use in a variety of environments, and ideas like many other cybersecurity solutions can be either host-based or network-based. Host-based IDS. A host-based intrusion detection system is installed on a specific endpoint to protect it from both internal or external threats. An IDS of this type may be able to monitor network traffic to and from the machine, observe running processes, and examine system logs. The visibility of a host-based IDS is limited to its host machine, reducing the available context for decision making, but it has deep visibility into the host computer's internals. Network-based IDS. A network-based intrusion detection system solution is intended to monitor an entire protected network. It has visibility into all network traffic and make decisions based on packet metadata and contents. The broader perspective provides more context and the ability to detect widespread threats. However, these systems have no visibility into the internals of the endpoints they protect. Decision method of IDS deployment. There is also a subset of IDS types. The most common variants are based on signature detection, anomaly detection, and hybrid detection. Signature detection. Signature-based intrusion detection systems detect potential threats by searching for specific patterns, such as byte sequences in the network traffic or non-malicious instruction sequences used by malware. The term signature comes from antivirus software, which refers to these detected patterns. Although signature-based intrusion detection systems can easily detect known attacks, they cannot detect new attacks for which no pattern exists. Anomaly detection. A newer technology developed to detect and adapt to unknown attacks primarily as a result of the spread of malware. This detection method employs machine learning to create a defined model of trustworthy activity, which is then compared to new behavior. While this approach allows for the detection of previously unknown attacks, it is vulnerable to false positives, which occur when previously unknown legitimate activity is mistakenly classified as malicious. Hybrid detection. A hybrid IDS uses both signature-based and anomaly-based detection. This enables it to detect more potential attacks with a lower error rate than using either system in isolation. There are a lot of IDS software exist. For instance, SolarWinds Security Event Manager. Logs from Windows, Unix, Linux, and Mac OS systems are analyzed. It manages snort collected data, including real-time data. CrowdStrike Falcon, a cloud-based endpoint protection platform with threat hunting capabilities. Snort, leading network-based intrusion detection system software provided by Cisco Systems and available for free. Suricata. For greater visibility, network-based intrusion detection system software operates at the application layer. Zeek. Network monitor and intrusion prevention system based on a network. Evasion technique. Knowing the techniques available to cybercriminals attempting to breach a secure network can assist IT departments in understanding how IDS systems can be tricked into missing actionable threats. For instance, fragmentation, sending fragmented packets to allow the attackers to stay under the radar, bypassing the detection system's ability to detect the attack signature. Avoiding defaults. A port utilized by a protocol does not always indicate the protocol that is being transported. If an attacker had reconfigured it to use a different port, the IDS may not be able to detect the presence of a Trojan. Low bandwidth attacks. Coordinating a scan among numerous attackers or even allocating various ports or hosts to different attackers. This makes it difficult for the IDS to correlate the captured packets and deduce that a network scan is in progress. Address spoofing or proxying. Attackers can obscure the source of attack by using poorly secured or incorrectly configured proxy servers to bounce an attack. If the source is spoofed or bounced by a server, it makes it very difficult to detect. Pattern change evasion. IDS relies on pattern matching to detect attacks. By making slight adjustments to the attack architecture, detection can be avoided. Now, the pros and cons of using IDS. There are some advantages of using IDS, and these are external hackers and network based attacks are detected, provides centralized management for distributed attack correlation. The ability to quantify attacks is provided to the system administrator. It adds an extra layer of security and provides all around defense. And disadvantages of using IDS are produces false positive and false negative. Full-time monitoring is required. It is costly and high skilled staff is required. So the next part will be continued by my groupmate. Thank you.
Now moving on to network attacks. So what is a network attack? A network attack is an attempt to acquire unauthorized access to a company's or organization's internal network for the purpose of stealing data or performing malicious activities. So there's two main types of network attacks. The first one is passive. So passive attacks are when malicious actors gain access to an internal network and either monitor or steal information, but without making any changes to the data or any systems. Active attacks are similar in the sense that malicious actors gain access to an internal network, like with passive attacks. However, their goal is to modify data and infect machines inside of the network. So now for the type of network attacks. So we have endpoint attacks where you gain unauthorized access to user devices such as computers or smartphones, servers, or other endpoints, and they are typically compromised via malware infection. Now for malware attacks. So this is where infecting IT resources with malware allows attackers to compromise systems, steal data, and do additional damage such as perform ransomware attacks. And lastly, our next is vulnerabilities, exploits, and attacks. Scanning victims' machines reveals vulnerabilities in the software or hardware used by the organization, allowing attackers to then plan their next stage of attack. Advanced persistent threats. A multi-layered attack using several avenues to gain access into a network, using off-the-shelf malware kits, social engineering attacks, or more specially designed malware kits for the attack at hand. Malicious actors usually have an objective rather than seeking financial or other forms of gain. The attacks are usually done during a prolonged period of time rather than in a large wave of attacks in order to properly get into the system, and then even if they are kicked out of the system, they can easily get back into it. So now on to common network attacks. First is unauthorized access. So malicious actors gain access to an internal network without receiving permission. Unauthorized access is usually a result of weak passwords, lacking protection against social engineering attacks, previously compromised attacks or accounts, and insider threats. Next to distributed denial of service or DDoS attacks. This is when a malicious actor utilizes botnets and large quantities of compromised devices to target networks or servers. False traffic is sent to networks in huge quantities, specifically sync or ACC packets, which can overwhelm a server and render it inoperable. It can also be done at an application level by performing complex SQL queries that can cause the database to crash. Next is man-in-the-middle attacks. So malicious actors intercept traffic mid-transition and steals the data inside of the packets, user credentials or any other sort of information inside of the packet, or modifies them to hijacks their function. If the packets are encrypted, the malicious actors will take the time to circumvent these defenses. Code and SQL injection attacks occurs when user inputs are not appropriately verified, allowing a malicious actor to enter SQL queries and acquire sensitive information. This is usually done, can be done on a web page where a user is required to enter their password or log in, something like that. And if the inputs are not properly verified, they can enter an actual SQL commands and retrieve additional data they shouldn't. Malicious actors can also perform an API call to pass malicious code, which is then executed on the server, compromising whatever data it holds. Privilege escalation. Once a malicious actor has reached the network and gotten access into a system, they can move on and expand their reach either horizontally or vertically. Horizontal expansion is when you infect additional systems of a similar security level, whereas vertical expansion is infecting systems of a higher security level, so managers, directors, CEOs, those types of systems. Next is insider threats. So malicious actors who already have access and security clearance inside of the company or organization, potentially some kind of employee at the company or organization. They don't need to breach any network defenses as they are already allowed to access the network, and then from there can implement systems and steal data and infect other machines. Now on to our project. Our IDS is built upon Python and Scapy to ensure it is lightweight, giving it the ability to run on almost any machine. So now you might be asking, what is Scapy? Scapy is a packet manipulation library with the ability to forge or decode packets over a wide number of protocols, send them via wire, and capture them, match requests, and replies. Scapy also has the ability to perform scanning, trace routing, probing, unit tests, attacks, or other forms of network discovery. Our focus was primarily on the detection of flood or DDoS attacks, so we give the user the option to track both TCP and UDP traffic. So here you can see the user has decided to track UDP traffic, showing possible suspicious behavior on the following ports. So it gives both the source and destination port as well as the source and destination IP, and this updates every time in real time when something comes up. Next is the ability to track TCP packets of different flag types, so sync, reset, finish, etc. After several hundred requests, the IDS will notify the user of a potential attack. So this is specifically against flood attacks or DDoS attacks. So here you can see the majority of our testing was done using Nmap, and we ran here a Nmap scan. It'll initially show that the flag as well as the TCP port destinations and source as well as the IPs and the flag used. Then after several hundred requests sent in short succession, the user will be notified of a potential flood attack. Now on to future goals. So we would like to monitor a broader section of network traffic beyond TCP and UDP protocols and evolve the system from a simple IDS into a intrusion prevention system, blocking any sort of attack such as a DDoS attack or any of the ones mentioned prior. So we would also like to include configurability such as just making it a simple packet sniffer, a packet logger, making it specifically an IDS or an IPS, and having it be ICMP compatible. We would like to give the user a level of configurability to spec the system out to how they would wish. We would also like to feature rules. This more so applies to the IDS and IPS, being able to log traffic incoming to certain ports, block traffic directed to certain ports, and ignore traffic based on whatever the user specifies or whatever rules they set. These are the references we used, and that is the end of our presentation. I thank you for taking the time to listen to it.